In this session, we have go over the fundamentals of objects and classes. We work through how to write a simple class rectangle step by step. Then we introduce the packages and import statements on how to put classes together and reference external classes. Then we go through instance fields and methods and compare that against the static fields and methods. And finally, we go through constructors. When you start writing a class, this is always the recommended approach that you create the class framework first, of course, with appropriate project and package. Then you create main method. So far, this has been what we are doing in all through this course. Then we are going to add more. When we try to create a class, we will first add static fields and static methods. Then we will add instance fields. Once instance fields is defined, we can create an instance by creating the constructors. Constructors can initialize fields, and then you can add setters and getters for each field. And finally, you can add business logic methods. So this is a very systematical approach, one step at a time. Let's look at our homework. So the first homework, we have 3 questions in this homework. The first one asks you to write a temperature class that will hold a temperature in Fahrenheit, which means there will be a double of Fahrenheit attribute. And provide methods to get the temperature in 3 different flavors: Fahrenheit, Celsius, and Kelvin. So the class should have the attribute, 2 constructors, and a setter and getter for Fahrenheit. And once you have a Fahrenheit, you also need to create business logic to convert to Celsius and Kelvin. And we also have the conversion formula here. Now, there are constants involved in the conversion, like 5 divided by 9, 32, 273. They all must be defined as private static attributes, because apparently these will not change no matter what their temperature are, right? Then the class must come with a main method, which will create 2 objects, one using non-arg constructor, one using argument constructor with arguments. Then create these 2 instances and display the temperature on Celsius and Kelvin. So this is the first question. Basically, what I'm asking you to do is to follow this step by step. There's no fancy stuff. Just by creating one step at a time, creating fields and methods. Similarly, we have a write class file converter with a constructor that accepts a string file as the source file, as its argument. So it will have the class will have a string file name as its attribute. And this attribute will point into a source file. Once you have a source file, you will be able to use your methods to create uppercase file and create a row chart count file. Basically, getting the source file and creating a new one. The new file name should be a string parameter of the method. For example, in this create uppercase, you already have the source file name in class definition. You will also have the string parameter of the method for a target. Then you will open up both files and convert all lines of the source file to uppercase and write it to target file line by line. And similarly, we have a create row count file. We have done the logic before, just in simple main method. All you need to do is to convert this into a object method and use object to wrap it up. And the third question is regarding our favorite store sales bar chart question. The original question is here, that you will get 5 stores, each and output asterisks based on how many sales you have. So the question states, in order to simplify the solution and prepare it for more requirements, let's create a store class. And this sentence actually summarizes the reason we want to create object. Why do we do object-oriented programming? Because we want to simplify the solution and prepare it for more requirement. Now for the simple store question, you may not earn much by creating classes, but once you have more code, it's much easier to create the classes divided code base into smaller modules. That will help you in understanding the code and understanding the requirement. The class should have store name. Right now, all store are store 1, store 2, store 3. This attribute will have a more flexible name, like 34th and Broadway, for example. It will only be initialized when the store is created. It's not mutable. Once you created this attribute, it's not mutable, but you can get the store name. That means it should not have a mutator, but you should have an accessor, right? And then you should have a store sales. And this is the cumulative sales. It will start with a 0. And every time you call add store sales with the transaction double, you should add the transaction amount to the store sales. So the first time when you initialize this in the store, its store sales is 0. Then you call add store sales 100, store sales will become 100. You call this again 200. Store sales will become the original 100 plus the 200 becomes 300. So this will calculate the cumulative store sales, and of course you have the get store sales. In addition, the store class should also have one more method, display bar chart, which will display store name followed by column and asterisks. The number of asterisks is store sales divided by 100. The class must come with a main method, which will create 5 stores, each with at least 2 calls to add store sales to get the cumulative sales. The main method will call the display bar chart method of all 5 stores to display the bar chart.